Okay, so today we're going to see change of units. But we're not going to see any change of units because you probably already know change of units. We're going to learn a new method for changing units. This new method is basically a step forward in trying to understand conversion factors, which is the most important way or the most common way used in science in order to change between units. But that's something you don't know yet. And the idea is to build or to learn first this intermediate step in order to understand better what a conversion factor is. So, what is the procedure we're going to learn in this video? Well, we're going to follow three steps. We've got here the table of the multiples on the meter and the submultiples of the meter that we're going to use as a reminder because you probably already know this. At least from the kilometer to the millimeter, then probably you didn't heard about the gigameter or the megameter or the nanometer or the micrometer. You probably didn't heard about those. But we will talk about them later, okay? Let's focus on the steps first. The first step of this method we're going to learn is to convert into scientific notation. Okay, scientific notation. So that's why we learned scientific notation on the last video, because we basically are going to use it in many forms. One of the forms is going to be making this method work. So first step would be to convert into scientific notation the number we're going to try to change units. Second step is going to be to change the unit. How are we going to change the unit? Well, we're going to change the unit through an equivalence. Okay, what's this? Let's see these first few steps with an example, okay? So the idea is as follows. If I want to change, for example, 3.6 kilometers, if I want to change it into meters, well, the first step would be converting that into scientific notation. That is already in scientific notation, okay? 3.6 is already in scientific notation. 3.6 times 10 to the power of 0 would be the same as 3.6. So that would be step number 1. In this case, we don't have to do anything. And we will move on to the second step. We will change the unit, so this is in kilometers, sorry. We will change the unit through an equivalence. Okay, and what's the equivalence? Well, basically, this table is the equivalence. We have to see that a kilometer is 10 to the power of 3. 10 to the power of 3 meters, right? 10 to the power of 3 meters. Why is this? We're going to learn it just now, okay? But the second step would be to change the unit through the equivalence. So we would the only thing we have to do is put the number we had before, and now we change this unit into a new unit, into the meter, by adding the equivalence. So since a kilometer is 10 to the power of 3 meters, we change where we had kilometers and we add the equivalence. This is the equivalence, right, between the kilometer and the meter. And how do we get this equivalence in general? Okay, so the idea is as follows. I would have something like this: kilometer, hectometer, decameter, meter, decimeter, centimeter, and millimeter. We will ignore the gigameter, the megameter, the micrometer, and the nanometer for now. And the idea is as follows. I have to count the number of times I had to move between one unit and the other unit. So I had to move 1, 2, and 3 times. If I have to move to the right, then the exponent is going to be positive. Whereas if I have to move to the left, the exponent is going to be negative. Okay, and that is basically how we're going to get the equivalence. The number of steps is going to be the exponent. And if it's to the right, it's going to be a positive exponent. And if it is to the left, then it's going to be a negative exponent. But x, in this case, the exponent of the 10 base power, is always going to be the number of steps I have to make between the one unit and the other unit. So that's basically the idea. Let's keep this in our mind to see a new example. Okay, we're going to finish. We're going to see a new example, and then we're going to finish with step number 3 of the procedure. Okay, so okay, let's try to change now. 2600 hectometers to kilometers. Okay, so the first step would be turning this number into scientific notation, which would be 2.6 times 10 to the power of 3 hectometers. And step number 2 would be adding the conversion. In this case, since the kilometer and the hectometer are next to each other, I only have to take one step. So the power is going to be 1. The exponent is going to be 1. And since I'm moving to the left from the hectometer to the kilometer, then the conversion factor, the equivalence we're going to use, is 10 to the power of -1. So we write down the number we had before, and now we add the equivalence. What's the equivalence between the hectometer and the kilometer? 10 to the power of -1. That's the equivalence between the hectometer and the kilometer. All right, how did we get the equivalence? By counting the number of steps. If it is to the right, then the exponent is positive. If it is to the left, then the exponent is negative. That's the idea we're going to follow in order to make this change of units work. And finally, last step of the three that we have in this method is making or multiplying the base 10 powers using a very simple rule that we probably have learned in maths, which is any number with a certain exponent multiplied by the same number with any other exponent can be solved by having the same number as a base and the sum as the exponent. Okay, this is the property, mathematical property we're going to use in here. In here we've got 10 base, so A would be 10, and B and C in this case would be 3 and -1. So if we go to this third step and multiply the base 10 powers using this formula, what we're going to get is the same 2.6, but times 10 to the power of 2. Why 10 to the power of 2? Because we're doing 3 plus -1. And as you probably already know, 3 plus -1 is equal to 2. So that would be the steps we're going to follow in making the change of units. And as I said, this new method is useful because it's going to help us work towards the end goal of understanding conversion factors. Basically, the equivalence we're trying to understand here is going to help us understand those conversion factors in the future, which are probably more difficult if we didn't make this intermediate step. I'm going to make another example just so we're sure we understood the steps of this method, and we're going to finish the video with that. We will be making lots of exercises, lots of examples in class for this, so don't worry if you didn't fully understood everything with this, because we will be doing much more things. So in order to show you that you can do this with any unit, not only meters, we're going to change now 25 liters to, for example, centiliters. Okay, so the first step would be writing the liters in scientific notation, which would be 2.5 times 10 to the power of 1 liters. And then we had to add the conversion. We write down the number 2.5 times 10 to the power of 1, and we add the equivalence. What's the equivalence in this case? From the liter to the centiliter, we're moving throughout the deciliter and then on to the centiliter. So we're making 2 steps to the right in this case. If we're moving to the right, remember that it's going to be a positive exponent. So 2 steps to the right is 10 to the power of 2. And this is the conversion between the equivalence between the liter and the centiliter. 1 liter is equal to 10 to the power of 2 centiliters. And then in step number 3, we will just make the multiplication. So we will get 2.5 times 10 to the power of 3 centiliters. And here we've got the quantity converted. This method is the method that we're going to be working with in this first months, and we will be working throughout the course in building those conversion factors for more difficult units and more complex units in general. I hope it was useful for you, this video. I hope you liked it, and see you on the next one. Bye.